Welcome to RK Tutorials. Solutions to Engineering Mechanics by S. Timoshenko. In this tutorial, we will solve problem set 2.3, problem number 2.40. A rigid bar with rollers of weights P is equal to 222.5 newtons and Q is equal to 445 newtons and its ends are supported inside a circular ring in a vertical plane as shown in the figure. That means there are two rollers P and Q. These two are attached with a string and these two rollers are placed inside a circular ring. The radius of the ring and length AB are such that the radii AC and BC form a right angle at C, that is alpha plus beta is equal to 90. That means ABC forms a right angle triangle and at C there is a right angle. Neglecting friction and weight of the bar AB, find the configuration of equilibrium as defined by the angle alpha minus beta by 2 that makes with the horizontal. Find also the reactions RA and RB and the corresponding force S in the bar AB. So our interest is to find the force in the rod AB, the reactions RA and RB and the angle alpha minus beta by 2. First of all, let us see where this alpha minus beta by 2. It is given in the problem that alpha minus beta by 2 makes with a horizontal. Where it is, how it is. Let us discuss that first. Given that at C we have right angle. So alpha plus beta is equal to 90. And also given that this AC and BC lengths are same. Hence AC is equal to BC. Now this angle is 90 degrees and these two lengths are same. That means ABC is an isosceles triangles. Since it is an isosceles triangle, this angle is equals to 45 degrees and this angle must be equal to 45 degrees. So this angle, these two angles must be equals to 45 and 45. Now let us draw a horizontal line from A onto this vertical line. Let that line is AD. And this is a right angle. Here clearly we can see it is a right angle. Now ACD is a right angle triangle once again. This angle is 90, this angle is alpha. So what about this angle? Let us assume that this angle is beta and we can say that beta is equal to 90 minus alpha. If this angle is beta, what about this angle? What about this angle? The total angle is 45. Just now we concluded by virtue of it is an isosceles triangle. And this angle is also, we know that is beta. So what about this angle? This angle is equals to 45 minus beta. 45 minus beta. But 45 minus beta, you can write 45 as alpha plus beta by 2 because alpha plus beta is given as 90 minus beta, and after simplification you will get this is alpha minus beta by 2. So this angle is alpha minus beta by 2. So that is the given. The defined by alpha minus beta by 2 that makes with the horizontal. That is already given in the problem and we already proved. Now our interest is to find the value of alpha minus beta by 2, this RA, this RB and the force in the AB. For that, let us draw the free body diagram of roller A and roller B. First of all, let us see what are the various forces that are acting on roller A. Clearly we can see the self weight, that is 222.5 newtons acts downwards. The reaction force RA which acts along the line AC because roller A is placed inside a circular ring, and the string force along AB, which is away from point A always, because we are assuming that the force in AB is tensile and which is away from the point of observation. Let us transfer all these three forces onto a separate xy plane for easy analysis. The first force, of course, P, 222.5 newtons. The next one is reaction RA, which acts along AC. And then the string force S, which acts along AB. There are three forces. All three forces are concurrent and all three forces are divergent. Let us discuss the various angles made by these forces. RA, we can see that RA is the force acts along that radius AC. And we know that this AC makes an angle alpha with the vertical, hence this angle is alpha. RA makes an angle alpha with the vertical. And S is the force acts along the bar AB, which makes an angle alpha minus beta by 2 with the horizontal, hence this angle is alpha minus beta by 2. Also we can see the angle between RA and S is 45 degrees. So this angle is also equals to 45. Now there are three forces. All three forces are concurrent and all three forces are divergent, and I know all the angles, hence I can apply the sine rule. Now according to the sine rule, force divided by sine of angle between the other two forces is constant. That means 222.5 force divided by sine of angle between other two forces, that is angle between RA and S, is 45. So I can write 222.5 divided by sine 45 is equal to RA is the force, RA divided by angle between the other two forces, that is S and 222.5, this angle. How much is this angle? So this is alpha minus beta by 2, and now I want this angle, so I can write this is 90 minus of alpha minus beta by 2. Hence I can write RA by sine 90 minus alpha minus beta by 2. That is equal to S divided by angle between the other two forces, that is 222.5 and RA. How much is this angle? Clearly mentioned that this angle is alpha. So this is another 90 and 90. So I can say it is 180. So this angle becomes 180 plus alpha. So I can write this one S by sine 180 plus alpha. Now let us simplify. First you take these two expressions and I can write S is equal to 222.5 by sine 45 into sine 180 plus alpha. So you can simplify further. I will get S is equal to minus 314.66 into sine alpha, because sine 180 plus alpha is equal to minus sine alpha. Similarly, take these two expressions. Then I can write RA is equal to 222.5 by sine 45 into sine 90 minus of alpha minus beta by 2. So that value is equal to 314.66 into cos alpha minus beta by 2. Similarly, take the free body diagram of the roller B. This is B. What are the various forces acting on B? Of course, the self weight Q always acts downwards for 45 newtons, and RB which acts along BC, and the string force along AB which is away from point B. Well, let us transfer all these three forces onto separate xy plane like this. First force 445 newtons. Next string force S along AB, and then RB which acts along the BC. What about the angles? Clearly we can see that BC makes an angle beta with the vertical and S makes an angle alpha minus beta by 2 with the horizontal. So this angle, say alpha minus beta by 2. Hence this angle is alpha minus beta by 2 and this angle is beta. RB makes an angle beta with the vertical. So this is beta makes an angle with the vertical and this makes an angle alpha minus beta by 2. So this makes an angle alpha minus beta by 2. Once again, there are three forces. All three forces are meeting at a particular point. So it is a concurrent force system and all three forces are divergent. Hence I can apply the sine rule. And according to the sine rule, force 445 divided by sine of angle between these two forces RB and S is 45. So 445 by sine 45 is equal to RB divided by angle between S and 445, this angle. So this is given as alpha minus beta by 2 and you know this is 90. So you can write 90 plus alpha minus beta by 2. You can write RB by sine 90 plus alpha minus beta by 2 is equal to S divided by angle between these two. So this is 180 plus beta. Hence I can write this force as S by sine 180 plus beta. Let us take these two expressions and you can simplify. You can write S is equal to 445 by sine 45 into sine 180 plus beta, and after simplification you will get minus 629.32 sine beta. Similarly, take these two expressions and I can simplify further. So you will get RB is equal to 629.32 into cos alpha minus beta by 2. Look at this. From free body diagram of roller A, I got S is equal to minus 314.66 sine alpha, and from free body diagram of roller B, I got S is equal to minus 629.32 sine beta. But both is yes because the force along the string is same. That means I can equate these two. So minus 314.66 sine alpha is equal to minus 629.32 sine beta. But we know very well alpha plus beta is equal to 90. It is the given in the problem itself. So I can simplify that beta as 90 minus alpha. So I can rewrite this equation, minus minus gets cancelled. So you will get 314.66 sine alpha is equal to 629.32 into sine 90 minus alpha. Sine 90 minus alpha is equal to cos alpha. You will get like this. Then you can simplify, that is tan alpha is equal to 629.32 by 314.66, which gives the value of 2. And you can simplify for alpha, and alpha is 63.43 degrees. If you know that alpha is equal to 63.43, you can calculate beta, since I know that alpha plus beta is equal to 90 and hence beta is equal to 26.57. Hence the required answer for alpha minus beta by 2 is equal to 18.43. This is the answer, one of the answer for this problem. Similarly, our interest is to find the value of RA, RB and also S. Since I know the values of alpha and beta, I can easily calculate the values of S, RA and RB. So from the free body diagram of roller A, I got RA is equal to 314.66 cos alpha minus beta by 2. Now I know the value of alpha minus beta by 2. I can substitute there 314.66 into cos 18.43, which gives the value of RA 298.52 newtons. Similarly, from free body diagram of roller B, I got RB is equal to 629.32 cos alpha minus beta by 2, and I can substitute alpha minus beta by 2 is equal to 18.43, and which results the value of RB. This is RB, that is 597.04 newtons. Similarly, I can also find the value of S. You can substitute either alpha here or beta here. So minus 314.666 into sine alpha, which gives the value of 281.43 newtons, but it is minus. What that minus indicates, initially we assumed that the force along the rod AB is tension. Since I got minus, so it is compression. So hence the final answer for S is equal to 281.43 newtons compression. So all these four are the answers for the given problem.